Let's look at this problem, students. Let A is equal to 18 and let B is equal to 54 and C is equal to 198. Suppose you're told that a number D is a factor of A. Which of the following statements must be true? And there are four statements and we should select all that apply. So we are told here that the number A, which is equal to 18, has a factor D. D is a factor of A. Okay. And also we are told that B is 54 and C is 198. And we are asked, is D a factor of B and is D a factor of C? And two more choices, which are D is a factor of B plus C and D is a factor of B minus C. Okay, now to do this problem successfully, we will have to understand the factor foundation rule. What does the factor foundation rule say? It states that if B is a factor of A and C is a factor of B, then C is a factor of A. C is a factor of A. That is, C would be directly a factor of A. Okay. Or we could rewrite it as like this. Okay. And of course, we'll remove this if we are depicting C there. Or we can have it just to show the relationships. So we will make use of this property. So if we have to find out if D is a factor of B, we need to find out if A is a factor of B. So is A a factor of B? Well, we know that 18 threes are 54. That's pretty obvious. So we know that B is a factor of B has A as a factor or A is a factor of B. And since D is already given to be a factor of A, D should be a factor of B. Okay, yeah, this is correct. What about C? Well, C is 198 and let's divide 198 by 18. If you have already detected the pattern, it should be a factor of 11. But anyway, you can go through the process of long division to discover that it is a factor of 11. 198 clearly is a factor of 11. So we know that A is a factor of C. Okay. So we have C, A is a factor of C, and then we know that D is a factor of A. Therefore, D is a factor of C as well. What about third one? D is a factor of B plus C. Well, this one is simple because if two numbers, let us say A and B, are multiples of another number M, okay, then A plus B is also a factor of, is also a multiple of M. If A and B are multiples of M, A plus B is also a multiple of M. Or to put it the other way, we can say if M is a factor of A and B, M is also a factor of A plus B. We can check this out with some real numbers. Say let M be 7. Okay. So multiples of 7, A is 14 and let's say B is 35. They're both multiples of 7. So A plus B is going to be 49, which is also a multiple of 7. And this is true for A minus B also, rather B minus A. Keep the result positive. B minus A is 35 minus 14, which is 21, which is also a multiple of 7. Or we can say that 7 is a factor of 49 and 21. Therefore, since we have already proven that B and C are factors of um, I'm sorry, since we have already proven that D is a factor of B and D is a factor of C, therefore D should be a factor of B plus C and D is a factor of B minus C. These two are also correct. We can also say that, B plus C is a multiple of D and B minus C is a multiple of D. So yes, all four of them are correct. All the following statements must be true. I hope this is clear to you now, students. If you have any doubts, you can always ask me in the comment section and I'll be more than happy to clarify. Thank you very much.